So area of plane figures, I've got a bunch of different pictures up here. So these are all formulas that you're going to see. So I just gave one example of each, and then I'll get to the more difficult ones. So parallelogram, treat it just like a rectangle or a square. This is just going to be base times height. So your height, the only difference is when you have a rectangle or square, you have the height because they're always a 90-degree angle. So to get height of something, it has to be a 90-degree angle from the lowest point to the highest point of a picture. So that's what this dotted line in here is. The actual parallelogram is right here. So don't think of anything about a triangle. You don't need that triangle. This is just showing you the height. So this would just be 18 times 30, and then whatever that is. So 18 times 30 is 540. Now, keep in mind, excuse me, keep in mind that area is meters squared. The reason why it's meters squared is because it's 18 meters times 30 meters. So meters, m times m, or like x times x is x squared. That's why you're going to have something like that. Volume, when we get the volume, it's going to be three things. It's going to be base times width times height. So that's why volume is always cubed. Okay, so that's all you got to do for a parallelogram. Circle, we talked about last unit, was pi r squared. So I just have to do 13 squared times pi. So if I do 13 times 13 times, and I'm just going to do 3.14 because I don't have a fancy calculator on me right now. And that's going to be 530 point, if I round to the nearest 10th, 7. So that's centimeters squared. If we do a kite, the kites are going to be 1/2, it's 1/2 times the diagonals. So diagonal 1 times, that's a terrible D. Diagonal 1 times diagonal 2 divided by 2. So you're going to basically do 1/2 times the sum of the product of the diagonals. So you're going to be multiplying those ones together. So if I do that, I got to get the whole diagonal. So this is 82. And then you're going to be timesing it by 40. And then you're going to cut it in half. Okay, so we've got a bunch of triangles in there, so maybe that's a way to help you to remember to put the half in there. So I got to do 82 times 40, and then I got to divide that by 2. So that's going to give me 1,640. And then units squared, but they didn't put anything, so I won't be fussy about you putting anything. Okay, and then a rhombus is going to be the same thing. So rhombus and kite, they have the same thing. Notice they almost look like the same picture. So rhombus is going to be the same thing, diagonal 1 times diagonal 2 divided by 2. So that's going to give me 40 times 20. And 40 times 20 is, I think, 800, but I'm going to double check. Yes. So that's going to give me 800 square feet or square units. Okay, so all you really need to know for these are the formulas. Down here, a triangle is 1/2 base times height. So some people have trouble remembering it. Everybody can remember that a square is base times height. I didn't even give you that one. But a square is always base times height. But if you think about it, a square is made up of 2 triangles. So it's going to be, if you just want the triangle, then it's going to be 1/2 of that. So that's where the half comes from, 1/2 base times height for a triangle. Same thing for the triangles, though. You have to be able to find that 90-degree angle, the lowest point to the highest point. So the height in that is 28. The base is 24. Now, when you do this, you can either, you don't want to take half of both of them. I've seen a lot of people do that. Do not take half of both of these. This is 1/2 times 24 times 28. It's not 1/2 brackets, so you're not distributing it. So I think it's easiest just to times the 24 and the 28 and then divide that by 2, kind of like we were doing with the diagonals. So if you just think base height divided by 2, that would be good enough. So this is 336. Now, the other thing you could do is you could just cut one of the numbers in half. So you could cut 24 in half and just do 12 times 28. That'll get you the same thing. So I gave you a tricky one over here because this one is one where if you're finding the area of the triangle, you've got to do a little bit of work. So I need to find the height. So if I'm going to find the height of this, the way I want to find the height is I want to use SOHCAHTOA. So right now, I've got a 90-degree angle because that's the height, and I need it to be 90. So I've got my 40 degrees. I've got my hypotenuse right here, okay? And then what I can do is I can find my height. So we'll just If you want to call that x, don't think of that as hypotenuse. So what I have right now is the opposite and the hypotenuse, which means I want to use sine. So if I use sine of 40, that's going to be the opposite over the hypotenuse. And then to solve, make sure you're in degree mode when you're doing this. So you're going to have to multiply both sides by 8. So if I do 8 times the sine of 40, that's going to give me about 5 point. And since we're going to use that to find something else, I'm going to put 3 to 4 decimals is always what you want to do. So I'm going to end up with 5.1423. And then at the end, you can round to the nearest tenth. So there's my height. My base is 10. So to find my total area, I'm going to do 1/2 times my base times that height. So if I do 1/2 times 10, that's just going to give me 5. And then I can do 5 times that number. So I'm going to get about 25.7 for this. Okay, so those would be the ones that are a little tough if they don't have their height. If they give you an angle in there, that's kind of a hint to use SOHCAHTOA. And then one that you're probably not used to is a trapezoid. So trapezoids, their area is 1/2 times the height times the sum of the bases. That means you're going to add the bases up. So this one you're probably not used to. Again, the height is always got to be lowest to highest. So you're looking for the 90-degree angle to find your height. So in this case, 1/2 times the height, and then you add up the bases. Just make sure they give you the whole thing. If they give you chunks, those are the ones that are a little harder, and you got to find the other piece. So in this case, the 40 is right in the middle, so that's all of it. So if I do 1/2 times 15, and then times it by 58, it's going to give me about 435. So just a quick run through of all of the shapes. Those are the ones that are normal and easy. Of course, I wanted to throw some tricky ones in here because these are the kind of things you're going to see. So first of all, I've got a square here. This is not a rhombus. If I've got all equal sides and then I've got my right angle. So the best thing I would say to do is to try to find your side lengths. Okay, so to find your side lengths, I've got these two things that are equal to each other. These are both 13s. And since this is 90, that makes these 45. Okay, so you've got your z, and then this would be your z square root of 2. So this would be 13 square root of 2. So if I'm doing base times height, that means I've got to do 13 times the square root of 2, and then I've got to times that by itself because you're doing base times height. So if you do base times height, that's going to end up with, 338. Okay, the other way to do it, this actually could be a rhombus as well. So if it were a rhombus, we do have your perpendicular diagonals, and you have all equal sides. So it could be a rhombus. So if you consider this a rhombus, then you've got 26 times 26 divided by 2. Guess what? You get the same thing. So whichever way works, it doesn't matter. Whether you did it this way or they do the 26 times 26 and cut it in half, both work. Okay, this one's not so tricky, but I just wanted to point out to you that this is a trapezoid. So you got to, if you have one set of parallel sides in a quadrilateral, you have a trapezoid. Okay, so in this case, you'd be doing the 1/2, the height, look for the 90-degree angle. I know that height usually is bottom to top, but in this case, the bases are here, so the height is this one. So I've got 1/2 times the height times the sum of the bases, which would give me 36. Okay, so 28 times 36 divided by 2 is 504 units squared. Okay, now over here, this one is definitely a rhombus. Okay, so I'm looking at it as a rhombus because it's tilted. So these are not 90-degree angles. Over here, I wasn't sure if they were 90 or not. You could have figured out that they were, but sometimes by looks, you don't want to go. So I've got 60 here, 90 there, which makes this a 30, 60, 90. So for a rhombus, you have to get the diagonals. So I need to figure these out. So with the 30, this is z. And then across from the 60 is z square root of 3. And across from the 90 is 2z. So to do this, what I can do is just divide both sides by 2. So these are sixes. Since it's a rhombus, it's going to cut them in half. It's parallelograms always have bisected diagonals. And then this would be 6 square root of 3, as is this. So now to do my rhombus, I've got to do the whole thing, which is 12. And then the whole thing here, which is 12 square root of 3. 6 square root of 3 plus 6 square root of 3 is 12 square root of 3. And then I'm going to divide it by 2. So you can do a couple of things. You can do the 12 times 12 to get the 144, and then divide it by 2 to get 72. So I would accept 72 square roots of 3. Or if you wanted to do the decimal, it would be about 124.7. I would recommend this one, but just in case, just so you can see both of them. So we keep bringing back the 45, 45, 90s, the 30, 60, 90s because you need it. All right, now this one over here. This one shows you that it is isosceles. So I've got 2 equal sides, and this is all it gives me. So if I've got a 90-degree angle and I know these two are equal, you can do x, and 90 equals 180. Or if you know that these have to be equal and that's 90, you know that this is 45. So there it is again, 45, 45, 90. This is going to be z, and z squared root of 2. So to be able to find your triangle, I need my base and I need my height. So I need those z's in there. What we did before, when we divided by a square root, is we did what's called rationalizing the denominator, which meant you did like this. So you wanted to get rid of that square root in the denominator. So square root of 2 times square root of 2 is 2. Can't really do anything on top. If you divide that, you get 5 square root of 2. So that's what we're timesing. So I've got 1/2 times 5 square root of 2, basically squared, because that's your height as well. I put that instead of parentheses. Really? All right, anyway. So 1/2 times your base times your height. So if I do this, square root of 2 times square root of 2 is just 2. So if I do 2 times 25, that gives me 50. And then if I cut that in half, I'm going to get 25. So 25 square units. Those are tricky ones that I thought you might want to see. And then these ones down here also, this is, I think I gave you 5 or 6 of these on tonight's homework. These are going to be where you have to compound it. So it's not a normal picture, but I see a right triangle here. So if I've got 1/2 base height, and then I need to add, because I'm going to add the area of this triangle. I didn't want to break it up into 3 triangles because an altitude doesn't necessarily break the 33 in half unless the 2 sides are equal. If these 2 sides are equal, which I don't know if they are, then you could say it's half, but it's not in this case. So I'm going to use the green triangle, which is going to be 1/2 base height. So I would just do that and add them up. Okay, over here, I need area of the big rectangle, which is base times height. And if I only want the shaded region, I need to get rid of the area of the little white triangle, which means I'm going to minus 12 times 5. Okay, so you want to get rid of the white part, keep the shaded part. Over here, I wanted to show you one like this because it's a bunch of pictures together. So you kind of have to make your own pictures. It is up to you the way you do it. So you can kind of cut it in like this. So if I went this way, that's one way to do it. Or I can go this way and make rectangles. It doesn't matter. Both ways are going to get you the same answer. So this little rectangle here is base times height. So 2 times 6. I need to add this area, which is 3 times, I don't know this whole thing. I know this part's 3. Opposites are equal. So that's 2. So you have to figure some sides out. So I've got 3 times 5 right there. And the big one right here is 3 times 8. So when you start to figure some sides out, you know that this part right here is 5. So you could do 5 and 3. That also gives you 8 in case they didn't give you that side. Okay? Other types are when they give you the area instead and make you find something else. So area of a rectangle is 48 and the width is 4. So if you're looking for area, you know that rectangles base times height, just start filling stuff in. Area is 48. the width, or sometimes they say base and height or width and length, is 4. So then what's the perimeter? So first of all, I need to find the other one. So if I've got the width, I need to find the length. So if I divide by 4, it's going to give me 12. So think of it like this. You've got the width is 4, the length is 12. So if they ask me for perimeter, add them all up. So this is 8, 20, 32. And if it's perimeter, it's just regular old inches. Area is the one that has squared inches or inches squared. All right, so area of a circle, pi r squared. Circumference, they gave you circumference in there. So circumference is pi times diameter. So they said the circumference is 10 pi. So I'm going to plug that in for circumference, which makes life easy because then these just go away when you divide them. So I've got the diameter, which is 10. I need the radius, just cut that in half to get the 5 right here. So 5 times pi squared. So 25 times pi would be good enough for that if it asks you in terms of pi. Okay, last couple. This says the area of a parallelogram to the nearest tenth. So I need the area of this parallelogram, which means I need base times height. So I need to find this height, and I need to find the rest of this because this only goes from here. So I only have from here to there. So a couple things I need to do. First of all, this is 127. Parallelogram have opposite angles adding up or that are equal, and consecutive angles that equal 180. So if I do 180 minus the 127, that's going to give me 53. So that's going to help me find everything. Now I can find the height, and then I could also find this piece that I also need. So SOHCAHTOA again. I've got the opposite and the hypotenuse. So if I do 5 times the sine of 53, that's going to give me, it's 3.99. So I'm going to just say 4. Okay, so that's my height. And then the other thing that I need to find is I need to find this piece. So I've got my hypotenuse and I've got the adjacent. So let's do cosine for that one. So cosine is, we'll just call it A for adjacent. So adjacent over hypotenuse. So if I do 5 times the cosine of 53, that's going to give me 3.00. So I'm just going to call it 3. So now I can do the area of my parallelogram. My base is 15 because it's 12 and 3. And my height I just found as 4. Okay, so this will just give me 60 and units squared is it. Okay, next I've got area of a trapezoid. So area of a trapezoid, as soon as I see that, I'm writing this down. Let's fill in what we've got. So we've got the area 60. We've got the height as 8. And one of the bases is 9. Doesn't matter which one you pick. What is the difference between, and then it's asking me something different. So let's figure out what the base is first of all. So I can cut 8 in half and get 4. And if I divide 60 by 4, that's going to give me 15. And if I subtract 9, my other base is going to give me 6. Okay, so now it says, what is the difference between the height and the smaller base? So I've got one of the bases is 9, my smaller base is 6. So that means I've got to do 8 minus 6 and to get 2 inches. Okay, last two. Difference between the areas of 2 triangles is 24. So if I've got, oh, that's supposed to say difference. So difference of 2 triangles, here's one triangle, here's another triangle, is 24. The height of each is 6. So what I can do is I can plug in 6. They said it's the same for both. And then what is the difference between the 2 bases? So what I can do is I can do 1/2 of 6 to get 3. And same thing here, 1/2 of 6 to get 3. So what I can do is I can factor out, because I know if we do 3b minus 3b, you get nothing. So what I'm going to do is I'm going to factor out a 3, because my bases might be different in this case. So we want to call this base 1 and base 2. So they're kind of different there. Now, if I divide both sides by 3, the difference of my 2 bases is 8. So they didn't give me 8 units. And the last one Parallelogram and a triangle. I made myself pictures. I'm visual. They have an area of 80. So that means this one's base times height. This one is half base height. And it says if each have a height of 48, so that means 48 is going to go in here. How many feet longer is the base of the triangle than the parallelogram? So I want to figure out what my bases are for both of them. So to do that, I could take half of 48 and get 24. And then I'm going to do 80 divided by 24. And that's going to give me 3.3 repeating. And then over here, half of 48 is going to give me the 24, and I'm going to divide, wait a minute, that's a B. So I'm going to divide 80 divided by 48, and that's going to give me about 1.7. So that's the bases of each one, and it says how many feet longer is the triangle than the parallelogram, so we just have to subtract these two. So I've got the 3.3 repeating, subtracting the 1.6 repeating, and that's going to give me about 1.6 repeating.